Hi guys, these are the notes for September 14th. We're going to talk about 1-6, solving compound inequalities. You already know how to solve inequalities. Now let's see what is added when we talk about compound inequalities. Let's get started. So our definition of compound inequality is two inequalities joined together by the word and or the word or. So let's see what that looks like. We're going to first work on this and type inequality. I don't necessarily see the word and in the problem, but I noticed something kind of interesting. I have two inequality symbols, and I also have this middle section. Imagine if this 23 were not here. Imagine that wasn't there for now. How would I solve this? I'd subtract 7, I'd divide by 3. I'm going to do that same process. I'm trying to isolate the variable. I'm trying to isolate y. But when I do it this time, I'm just going to have to add 7 in 3 places. 1, 2, 3. So on the left, in the middle, and on the right. So let's see how that looks. I'm using my inverse operations. The inverse of subtraction is addition. So add 7. Add 7, add 7. Notice how I had to do it in 3 places instead of 2. So let's go ahead and see what we get. 8 plus 7 is 15, is less than 3y, is less than 30. From there, I still need to get that y alone, and I want it to be in the middle alone. So let's see what we need to do. The inverse of multiplying by 3 is to divide by 3. So let's divide by 3 in the middle and on the left and right. And what are we left with? 15 divided by 3 is 5, is less than, that cancels, so we just have y is less than 10. So I'm thinking, whoa, that's interesting. How do I graph that on a number line? Well, let's see. If I notice one thing about this, let's think about what we do know. We do know that these are going to be open circles because they don't have an equal to with it. So let's go ahead and just put those numbers on our number line. We have 5 and 10. And like I said, they're both open circles. Now we have to look at this. Look at it very carefully. The y is between 5 and 10. If you want to just cover up the 5 for now, notice that y is less than 10. And going the opposite way, y is greater than 5. So y is between 5 and 10. And in the problem, the y is literally in between that. So when I do my shading, I'm going to shade in between. Anytime you have an and type problem, it'll look this way. I'll have 2 numbers on my number line, and I'll be shading in between. It kind of looks like when you're lifting weights, a weight, that's what it looks like to me. All right, let's try another one. This is another and example, but I noticed one thing here. I have variables all over the place. The only place I want a variable is in that center. So let's see what we can do to get rid of the n on the right and on the left. What I'm going to try is subtract n in all 3 places. And let's see what we have left. These cancel, these cancel. I have 6 is greater than 2n minus n is 1n plus 5. That's canceled. So it says greater than -2. Let's go ahead and continue to solve this. Try to get that n in the middle. So I'm going to subtract 5 on all 3 parts of my compound inequality. I have 1 is greater than n is greater than -7. All right, here's the thing. In my personal opinion, I do not like the way this looks. Why? Because that -7 is on the right hand side and the 1 is on the left hand side. In my opinion, I like to have them always with the less than sign instead of greater than, it's how you'll see it. I want to say 80 to 90% of the time. This isn't incorrect, but it can be confusing on how to graph it. So what I'm going to do in order to fix this, it's an easy fix. I'm still going to keep my n in the middle, but I'm going to reverse my signs and my numbers. So that -7 I'm going to bring over to the left, and that 1 I'm going to bring it over to the right. Is it incorrect to leave it like this in blue? No, not at all. You definitely can, but you will hardly ever see it that way. And whenever you graph, it might be a little bit confusing because -7 is a smaller number. You would think, hey, that's on the left. And then the 1 is the bigger number, that's on the right. Let's see how it looks. -7, 1. I put my numbers on the number line. I have to decide if it's open or closed circle. Open, open, and see, look, n is less than 1, so I'm going to shade this way. But going in reverse, the n is bigger than -7. So again, this is how and looks, shaded in the middle. So this is your solution. Either of these are your solution. You could use this. It is technically correct. Like I said, you won't see it, but maybe 10% of the time. You would get full credit if you had that answer on a test, but I personally prefer it written here in red. Let's try another one. This is going to be our last example today. This is an OR inequality. And what's going to happen is I'm literally just going to work out two inequalities separately. K plus 6 is less than -4, or 3k is greater than or equal to 14. Let's just work them each out. So subtract 6. This is my first problem here. Let's go ahead and work it out. K is less than -10. Or let's go ahead and work this out. When it says or, it's not giving you the choice of choose one or the other. It's an entire problem, but it's compound, and that is basically going to give me a hint to how it's going to look on my number line. So K is greater than or equal to 14/3. You can probably try to figure out in your head what 14/3 is, but I noticed one thing. I noticed that this is positive and this is negative, so this will definitely be my number on the left on my number line. It's smaller. So -10 and 14/3 are both going on my number line. If you want to change that to a decimal or something like that, you can technically, but in class usually you'll just leave it as that improper fraction. Told you not to be scared of fractions. Let's look at the 10. K is less than -10. So I have to think open or closed circle, open. And I also have to think left or right. Well, less than would be left. Okay. And now let's look at this next one with 14/3. I have to think open circle or closed circle, closed. And then I have to think left or right. It says greater than, so that would be to the right. So this is what an OR inequality would look like on a number line. Remember, and they both went in facing each other, or they're splitting up, they're going apart. This is where you would have a union if you had to write it in interval notation. All right, guys, see you tomorrow.